All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to continue learning about Rust. More specifically, we're going to focus on iterators, just as we did yesterday. I believe yesterday's thing was also iterators, or did we? I don't remember exactly. Though I do remember diving deep into iterators and going down quite a bit of a rabbit hole, let's say. In a good way though, because I got to learn so much from this. Prior to this, I didn't even know that. um well, I didn't understand that whole thing about there being a type parameter in a trait. So like when you're defining a trait, then you define a field called type, and then when you're implementing that trait on some other type, then you have to actually specify what the type is. And the interesting thing is, you can mix this up with generics and use the generic type that's being passed in with the struct. You can use that type for this type of the iterator, and that's kind of what happens in this case. Hold on, what's a good way to what's a good way to specify it or show this? Because I did, holy shit, dude, I did a bunch of research on, wait, hold on, let me open up my stream chat. Also, every like half an hour, I'm gonna be stepping away to, hold on. Yeah, every half an hour, I'm gonna be stepping away to go stir my food because I've got some food on the fire and, well, I don't want that to burn. So I've kept it on a super low flame. And as I'm streaming, it's gonna, every half an hour, I'm gonna go and stir it. And like as I'm streaming, it's gonna keep cooking. So hopefully by the end of the stream, even the dish is ready. And then I just need to boil some rice and I'm good to go. Yeah, okay. So I have been doing a bunch of research. Where do I even like begin, dude? I made a social media post shortly before starting the stream. I also got another idea for something I want to do in Rust with Rust and Godot. Because I'm often in situations where I want to build a very simple electronic circuit. Well, I want to build a digital version of a very simple DC circuit, right? But then there aren't necessarily straightforward tools. Well, I don't know if straightforward is the best term to use there, but like I I'm looking for something that's really simple, really lightweight, not even running simulations, literally just designing the circuit. There are a few tools that I've seen, and they probably do a much better job than whatever I'm planning on making. But I still want to make my own thing because I feel like my own tool, I'm gonna be using it so much more. There are plenty of tools available. I'm just looking to make my own, really lightweight one. And I want to see how good of a job I'm able to do when I'm doing it in Rust. There's going to be quite a bit to explore in within this domain because essentially I'm going to be creating a graph of sorts, right? I'm going to need to look into how to manage connections for each of the nodes, and just in general, like the idea of nodes itself, like the I don't know if I'll have to like create my own graphing system. If I do have to, that would be something interesting to look into as well. But yeah, there's going to be quite a bit for me to explore within that domain. And I feel like that should be a pretty good practice for me of both Godot and Rust, because there's going to be fairly complex things that I'm going to be doing in both of them. And because of this, I'll get a chance to explore both of them extensively. And of course, this is going to be an open source tool. So once the thing is ready, I'll put the entire source code and a build of it up on GitHub. So anyone who wants it, they can, download it, use it as is, or modify it, and whatever. Oh, I'll also open it up to other people being able to contribute different types of nodes. In this case, the different types of nodes are going to be various DC elements. So my very basic stuff that I'll be implementing is based on what I am going to be working with initially, which is your incredibly basic discrete components, stuff like resistors, capacitors, diodes, LEDs, so light emitting diodes, switches, and simple power sources like batteries. I can also have something as a current source, but like I'm mainly playing around with batteries, so I'll have battery. I might have I could add a 12-volt DC source, which is just like a voltage source kind of thing. What else? What else? Transistors, that's another one. Specifically BJT transistors. And to be clear, all of these things that like this specific thing that I'm trying to accomplish, building this incredibly simple circuit and all of this, there are tools available out there that let you do this, but I'm looking for something super, super simple, super bare bones. And I feel like it would be a good practice for me if I tried to implement something by myself. And I'll also open it up to, other people being able to contribute their own various types of nodes. So people can contribute through like a PR, a pull request on GitHub. And that way, other people, if they want to contribute, let's say, an inductor component, or I I can't even think of like what more. There's plenty, by the way, plenty of DC components out there that people use for various things within a DC circuit. An opto isolator is one. That is, yep, okay. An opto isolator is definitely one of the things that I can add to the, list. The point is, right now, whenever I do make this thing, I'm mainly only going to be adding in the components that I currently have and use. I'm not going to be adding like all of the components out there. So as people feel the need to, they can create their own node kind of thing, their own node definition, let's say, and they can share it. So then I'll add that to the list, and whenever whenever you download like the latest binary or something, you can use that updated node library. Okay, that being said, what all did I dive into? I've spent like between yesterday's stream and today's stream, there has been so much that I've been diving into, and it's just been question after question after question for Gemini, and Gemini has been helping me immensely to learn all of this stuff. I learned about like iterators, stuff like, okay, so when we do something like so okay, we have iter, right? I learned that iter is actually the struct in this case, and iterator and into iterator are both they're both traits. I believe I did this on stream yesterday. One place where I did get stuck was in this thing. What was it exactly? Into iterator. So I had noticed that into iterator. Oh, I actually don't remember if I did this on stream or not, but I had this thing where I'd set up a trait bound. Because okay, I do remember setting this stuff up and then trying to pass these things into this sum func or one function to see if it works. And what I found is that I was able to pass it when I limited when I created a trait bound for, I need to I need to learn the way to, I need to learn the vocabulary here, because I kind of, it always trips me up when I have to like use it in a sentence. Because like, okay, um, what was I saying? Yeah. So I set up this generic function with this generic type parameter, and I created a trait bound for it. So that's one of the requirements, that this type, whatever type is being passed in, it has to implement into iterator. Now, vec implements into iterator, because of which you're able to I was about to say that it implements into iterator, because of which you're able to get the iter function, but I don't remember if that's the exact reason why you get the iter function. That's why you get the into iter function. I don't remember if that's why you get the iter function itself. I don't remember where that comes from. Hold on, hold on. Let me just open up a new Gemini conversation so I can give you guys the accurate information. In Rust, I have a vec I32. I'm able to use into iter to get an iterator out of the vec, and possibly, actually, does that consume the vec? Hold on. Uh, v2 v2 is, yeah, v2 is a vec. Into iter. Yeah, this consumes it. Okay. Man, I'm so glad that I'm actually able to like just figure this out by myself. Looking at the function signature, it says fn self and not fn ampersand self, so I know that this is gonna consume it. Okay, anyways, so I know that okay, so into iter consumes the thing. Okay, and possibly consumes the vec. But I'm also able to call iter to get an iter. I know that into iter is possible due to into iterator being, hold on, I spelled iterator wrong. Into iterator, no, I didn't spell that wrong. Into iterator being implemented on vec, but what about iter? Now give me a second while, okay, this is a great observation. In Rust, the difference between into iter and iter, oh, hold on, often trips people up, because they seem to do similar things but have very different under the hood mechanics and ownership rules. The short answer, while into iter comes from the into iterator trait, the iter method is actually just a standard convention in Rust. It isn't tied to a specific iterator trait in the same way. Instead, it's a method explicitly defined on vec and most collections to provide an easy way to get an iterator over shared references. Now, as I'm reading this, I'm glad that I read this, because I just learned yet another thing, which somehow this question didn't occur to me as I was doing extensive iterator related research yesterday. But I'm words. But I'm glad that the question came up now, and I, did the research on it. What was I doing? Yeah, I don't remember why I was looking into this, but okay. So going back to, wait, let's delete this so there's not. So going back to this, right? I'm able to call some and pass in a vector or a vec into this. but I'm also able to pass in an iterator itself, which I found interesting because I was like, okay, vec implements into iterator. Why am I able to pass in iterator though? Does iterator also implement vec? And it turns out that this comes under the concept of like blanket implementations, which is a thing in Rust, and that was super interesting to explore. And that also kind of introduced me to some new syntax, which was something along the lines of like impl I, um, and then let's just pick a trait, I guess. Do I have some trait? Yeah, for I. Is that good? Not all trait items are implemented. Okay, yeah, that's fine. We can generate it. Implement missing thing, and in here we can pass in I. There's still an error. Conflicting implementation of trait some trait for type. Hold on. Okay, wait. I don't remember this. So I just wanna because I wanna tell you guys about the blanket implementation thing. That was a really interesting concept to explore. Let me just open up that conversation. Understanding Rust iterators, blanket implementations. Okay, okay. Where is that conversation? Was it this one? Maybe it was this one. Or maybe it was this one? It was this one. Okay. Um, Here there was something. Well, okay. We can explore blanket implement. Wait, hold on. I can wait. Let me do this. It's a blanket implementation. The logic is if you are already an iterator, you can convert into an iterator by simply returning yourself. So this is the blanket implementation of into iter on iter. And I found that really interesting. Like I was trying to find out does into iter or does iter actually implement into iter, and then I went into the documentation for into iter, and under that there's a section called blanket implementations. There's literally a section called blanket implementations, and if you look under that, was it into iterator or was it, where was it? Hold on just a second. I'm yeah, it was somewhere here. There's implementers, and then there was, where exactly was that? Was it into iterator or was it iterator? I think it's iterator that's hold on just a second. Required associated types into iter. Okay, okay. Where was it, dude? It was somewhere here. It was definitely somewhere here. This is a trait into iter. And I remember asking Gemini for clarification, like how do you know that it implements it for sure? And then Gemini had pointed out that yeah, there is an implementation on so and so page. You can go and check it out. Into iterator documentation. Okay, into iterator in std so and so. Okay, required associated types, required methods. Okay, traits. Where's that blanket implementation section, dude? Give me a second. I'm trying to look up the term blanket here, but it's not showing up. Though it showed up yesterday. I wanna show that on stream. There's Where exactly was that? If you go to the official Rust docs for Iterator and scroll down, you won't see into Iterator listed there. However, if you check the into Iterator documentation, you will see the blanket implementation listed under implementations on foreign types or implementers. Oh, there is an implementers section. Let's open up implementers. There's macros. There, dude, there definitely was a blanket um, a blanket optimizations section, but where's that gone? Why did that vanish? Okay, I can't find it right now. Maybe in tomorrow's stream I can show it. But I'd seen it, dude. I'd seen it because I remember I copied this um and pasted the thing into Gemini so I can get some information about the so I can get some information about what the code was saying exactly. I even copy pasted the code. I can copy paste that code here. Hold on. There was this code. So I'll copy this code. There was a blanket implement, dude, there was definitely a blanket implementation section. Into iterator, blanket implementation. Blanket into iter implementation, a blanket implementation of trait like into iter below me, made to work, or will coherence not allow it? Okay, into iterator in standard iter. By implementing into iterator for a type, you define how so and so, so and so. Okay, all right. Give me a second here because okay. I think the machine is running out of RAM. Give me a second. Hold on. Not that much. Yeah, not that much. There's something else going on. There's definitely something else going on because of which it's slowing down. That's okay. Now, where was it? Required methods, implementers. Dude, this is crazy. The 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 thing was there yesterday and I'm not able to see it today. Hold on. So this is the trait, and under this trait, we have okay, required associated types, item into iter, required methods into iter, implementers. Okay. Give me a second. I'm just going through this entire thing. Okay, this is odd, dude. I definitely found it yesterday, and today it seems to have like vanished. I need to look into this. That's really weird. Why the thing is just gone. There was definitely a blanket implementation section, which seems to be missing now for some reason. But anyways, okay. I explored that. I also got to explore associated types, which is where you are able to specify a type within a trait, and then when you're implementing that trait on a struct, then you have to specify the type. So what you can do is you can create a container for a type within the trait, and then you can assign the concrete type when you're implementing um, the trait on a struct. Or in the case of generics, you can assign the generic type to that empty type, and you can then use that type in various ways. So in the case of something like a vec I32, what's a good way to show this? So here you can see T is I32, right? And this we are getting back an iterator. Um, is it shown here? Yeah. If you look here at the closure that's being passed in, the closure here says self.item. Item is the name for the container for the type that they've given. That is why we are passing this in. And what we are saying is we want a reference for that type. In this case, I'm not sure if that's supposed to be a reference to the vector itself or a reference to, I think it's supposed to be a reference to the vector, not a reference to, um, is it supposed to be a reference to the vector or to the type? I'll have to like think of the levels here. Wait, are you guys able to see this on stream? I'm not sure. Oh yeah, I think it's showing up on stream. Yeah. So the closure takes in something and then returns a bool, or it's supposed to return a bool, and then that is being, oh, it's returning one bool, right? So the type in this case is not a vec. The type is um, the type of the element. So in this case, it's I32. It just doesn't mention item equals I32, but yeah, in this case, it's I32. I forgot why I was doing this. I think I was just trying to show that this is one of the things. This is the type. If we go and look at the um, actually, yeah, we can do that. Wait, in the Rust on the Rust website, we can do that. Give me a second. Let me like, you know what? If I am going to BRB, it is almost 30 minutes into the stream, so I'm just gonna step away for like 2 minutes, or I'll try to make it 1 minute, and I'll go and stir up my food, and then I'll come back. Okay, I'm back. Back to what I was doing here. Oh yeah, I was gonna show. Hold on. I was gonna show um Rust iterator or Rust iter, I think. Yeah, iter. Um, Apparently this is from Slice. This is from the Slice. What do you call it? This is from the Slice module. I think this is the one that I'm supposed to be. Hold on. I mean, I just have to show like one. Well, no, I think they'll each have like different implementations. So it's best if I show the actual one. And this thing is taking some time to load. Okay, let's close that and close this. And okay, composable external iteration. Structs are often the return types of various methods. Okay, iterator. And um wait, so what implements iterator? Oh, it's oh yeah, that's what I'm trying to show. I'm not trying to show iter. I'm trying to show iterator because the iter struct implements the iterator trait. Yes, okay, my bad. It's iterator that I was looking for. I was looking for the iterator trait so I could show you guys this. So this is the iterator trait, and whenever you implement this for a certain struct, you have to specify the type. So in this case, it says item, um, and that's a type, which I found interesting. Apparently, this is called an associated type, and I'm still like doing a lot of research surrounding that because I wanted to know what more are we able to add into a trait similar to how we have type here. And I think I've seen in another case there was output. I don't remember what output was supposed to be. One way to find out is to like recreate the thing. Hold on. So we can close this closure thing or delete the closure thing and create a function here. This can be a generic function. I forgot what the syntax is. Hold on. Where does the I think it comes here, right? Let's say some func o1, and then we do a. Oh, yeah. Let's remove this because I'm trying to get I think it's Clippy or the Rust analyzer, one of these two. Yeah. Okay. Is defined in multiple. Okay, I think I defined it above. Right. So expected a type, found a trait. I think I need to do impl. In fact, I was supposed to do the where thing. So let's do this and then remove this implementation from here to here, where T implements partial. Why is this not? Oh, wait. Hold on. Is it supposed to come here? Is that the problem? I don't hold on, dude. I don't remember where okay. Is it here? Okay, it's here. Where T, and now it should work. Okay. T implements partial or where exactly, how exactly had I gotten it to, like there was something relating to partial ord that made it how was I doing that? Oh, wait, okay. So in here, we want to take in two variables. Okay, both of them have to implement partial ord, and then what we want to return is a bool. Let's actually no, we can return t. Wait, what's the issue? Implicitly return. Okay, yeah, that's fine. I'll be fixing that. Mismatched. Oh, it's because I haven't done. Yeah, okay. Yeah, that's fine. Um, A equals or A greater than B. So we are trying. Yeah, okay. In this case, you know what? I'm trying to do multiple things here, and I'm just kind of confusing everything. I can't remember. I can't remember what exactly it was. How exactly did I um, introduce that? But there was a thing. Oh, there was a thing for addition. Yeah, add. That was a thing. And then I can return this and pass t, right? And then we get this. This is what. Hold on. Where is yeah? Consider further restricting this bound using this. So with add, you get you can then specify this output thing, and this is what initially I didn't know. Actually, back when I had seen this, not even like so. Back when I had seen this, I didn't know exactly what this meant. So I was kind of confused that okay, what is this? Extra set of angle brackets and output equals t and stuff. So now I can explore this further. The item thing where we specify a type, that is also one similar situation. I'm guessing this is also something similar to that, the resulting so and so. This is a type, public type output. This is a type. Is the implementation shown somewhere here? Um, Even if it's not shown, we can like, wait, does it mention something about output somewhere here? Okay, output here. Notice that the implementation uses the associated type output. Okay, okay. I can't find that thing. Um, that's fine. Okay. But yeah, anyways, I at this point I even forgot why I was showing you guys this. Anyways, dude, you know what? Let's just continue with the learning about iterators. So the exercise that Gemini had given me that had to do with filter and map, And before jumping into filter, actually while jumping into filter, before actually using filter, I decided to take this whole detour that taught me so much, dude. Holy shit. There's just so much that I learned from this thing alone. Um, okay, now in this case, I know, and I'm kind of glad that now I'm able to read whatever is here. Now I'm able to better understand this entire, hold on. Now I'm able to better understand this entire section. Actually, does iterator implement filter? It does. Or is filter one of the methods of iterator? It is. I wonder if there's a way to um, make certain methods optional. Yeah. I wonder if there's a way to make certain methods optional because let's say I tried to implement iterator. What all would I need to, okay, so let's say struct, um, I don't know, I think I have my struct O2, so let's do my struct O3, I32, okay? Wait, do I need that? Why am I doing this? I don't remember why I'm doing this. Okay, wait. So impl iterator for um for my struct O3. Okay, and then we do type item equals I32 because we know that's the type. And then what is, oh, there's a whole list of, do I have to implement all these functions? Or is it going to throw an error? Like in the error, at the very least, you need next, right? But like, okay, implement the missing item next. All right, let's, so there's missing members and default members. Let's see what each does. Oh, God. Okay. Holy shit. That's insane. That's crazy. It generated all of this code. It generated all of the code. What did I click on? What was it missing members or okay, so the missing member is implemented and the others are not giving and they're not giving any errors. So those seem to be optional. Why was I doing this? I forgot why I was doing this. I was in filter. Dude, I need something. This is crazy, okay? I need to build something that listens to what I'm saying and actively builds a mind map out of it. That would be a crazy project to set up. Like actively building a mind map out of whatever I'm saying. Give me a second. I'm just going to note this down. Heavy NLP. Actually, wait. Live speech mind map. Actively build mind map based on speech. Heavy NLP. This will be an interesting project to get into if I ever get into it. Because I'm definitely not going to be using LLMs for this. That's like way too. You know what? No, because the processing can still be the thing has to be done real time, but how late, as in the delay for it, the latency for it, that's not really that big of a deal. So like even if it takes a couple minutes to generate the mind map and change the mind map, um, what was I saying? What was I just saying? Uh, Even if it takes a couple minutes to generate the mind map, that's not a problem. As long as the speech is still being actively, recorded and queued up somewhere, so that it can be, used for further analysis or analyses. I'm not even sure how I'm going to be going about this whole thing. Dude, this should be an interesting project. This should be an interesting project. And what I have in mind is generating something like Hacker Mind Map. Though, I mean, it doesn't, to be fair, it doesn't have to be Hacker Mind Map specifically. I can do like um, what was I saying? My God, dude, my concentration is like all over the place. This doesn't have to be Hacker Mind Map specifically because Hacker Mind Map is it's a mind map tool for the terminal, and I would love for it to be terminal based, but I can do it in two ways. Um, I'll build the thing in Rust, that's for sure. I'll build the thing in Rust. I'm thinking of doing Godot or using Godot for rendering, but like that's not like a strict requirement. I can I could you know what I could make the thing agnostic, rendering agnostic. So I can build the system, and then when the time comes for finally rendering it, then the rendering will change based on whether we are rendering to a terminal or rendering it in Godot. I'll make it agnostic, but I'm not going to implement the TUI part of it just yet. Or maybe I should implement the TUI part and not do the thing in Godot. Though if I do it in Godot, if I do it in Godot, um, it's gonna give me good practice of doing stuff in Godot. Yeah, yeah. This should be interesting. This should be interesting, dude. I need to hold on to this idea because there's a lot to explore here. I need to hold on to this idea. Wait, I need to write down these other ideas. Working. Um, as user speaks, program records audio chunks and um, feeds them into NLP models. I have no idea. I have like zero idea about NLP. I'm just trying to find the most lightweight way of doing this. And I feel like rather than rather than full on language models and LLMs and stuff, I would be able to achieve a bunch using um, using bare bones NLP models or even like bare bones NLP methods. Though I feel like models would be more accurate there. Though there's going to be ASR involved in that. I just realized that. Yeah, yeah. I just realized that there's a certain level of transcription that needs to be done there. That's going to be a problem. Yeah, I need something incredibly lightweight to um, do the transcription. Let me see if I can use some of the more lightweight models from I forgot which model I was using for doing the transcription in the other situation. I think it was the one of the Facebook models. No, I think it was Distill. It was Distill Small EN. That's the one that I was using, and that is already the small version. That is already, the lightest one that they have. Maybe there's one smaller than that as well. Let me see. I'll have to figure out a good, because, like, yeah, I just realized this. As I'm No, this is okay. Hold on. This is wait. Hold on. I need to finish writing this down. I'm writing this down in a different place, but I think I can copy it from. How would I go about copying it from that one to this? So what gets copied is, okay, what if I'm trying to paste? Okay. As user speaks, program records audio chunks. Let me just look at the time. Okay, almost time to go and check on my food again. But yeah, as user speaks, program records audio chunks and feeds them into NLP models. No, program records audio chunks and feeds them uh, into an ASR model to generate transcript. The next step is transcript is fed into NLP model to generate a thought process mind map. Yeah. Now I'm gonna have to see how to go about. Um, I'm gonna have to see how to go about generating the mind map for the thought process, because what it's supposed to do is pick out the topic and then what that branches into, and even what is branching into, we have to pick out the topic for it, not necessarily, you know, show the entire sentence. Anyways, okay, let's get back to this. We haven't really done anything. To be fair, we have been talking a whole lot about iterators. And I kind of forgot why I was doing this next thing. Oh, this reminds me. Yeah, let's ask Gemini. Um, Hey, I'm doing Rust coding. I'm trying to, no, I implemented iterator for my struct on my struct. I noticed that the Rust analyzer only complains about, what's the exact name? Next. Okay. Only complains about next not being implemented. The other methods are optional. How do I do this in a trait? This is a great observation. What you're seeing is a fundamental feature of Rust's trait system called default implementations. In Rust, a trait can provide a standard version of a method. Wait, in Rust, a trait can provide a standard quote unquote version of a method if a type implements that trait but doesn't provide its own version of the method. Rust uses the default one instead of the trait itself. Oh, is it literally as simple as the trait, the function having, or each of the functions, each of the methods having their own bodies defined already? I think that might be it. So like let's delete this. Let's create a trait here. Trait, my trait, O2, I think. Is that okay? Yeah, that's okay. Fn some func. Yeah, that's it. Though if this is being implemented on the trait, do I not need the self thing? So let's hold on. Impl my trait O2 for my struct O3. Now here we have this. That's done. Okay, that's interesting. Oh, that would be the difference between it being an associated function versus it being an instance function or an instance method. So in that case, I would be doing something like um, my struct O3, and then we have some func O1 mentioned there. Okay. All right. What else was I gonna do? Oh yeah. So fn some func O2, and we don't need to implement that, right? So if I delete this, it complains because there's something missing. Implement missing members. That's the missing member. Implement default members. That's the default member. Okay, so it implements the default member, but it doesn't implement the missing members. I also like that we have the option to, hold on. This is, okay, this option is coming from the Rust analyzer. I think in the past I've been saying that, oh, this is coming from Clippy, these code action options. Yeah, I don't think it's coming from, I don't think it's coming from Clippy. Give me a second here. Okay, we are good to go. Oh, actually, real quick, there's something else that I need to do here. Let's move this up here just so I can see it. Perfect. Awesome. Now, yeah, in the past, I've been saying that this was coming from Clippy. I think I was wrong about that. The code actions are being apparently it's thanks to the Rust analyzer, not Clippy. I was looking at these colors. So if you look at the colors here, this color, it mentions this is coming from Rust C. The red thing is also coming from Rust C. But based on the color, I was assuming it's from Clippy. And now I feel silly because in the past couple of streams I've been saying Clippy. This is mainly the Rust analyzer. Anyways, so what was I gonna do? Oh yeah. So we can implement the missing members. We can also implement the default members, and we are good to go. This is crazy, dude. This is holy shit. This is amazing. This is actually amazing. All right, I forgot why exactly I was doing this. Oh, I think I was doing it because of this. Yeah, I think I was doing it because of this. Dude, now each time I try to remember, all the way back what I was trying to say, I keep thinking about like, what if I had an automated tool that could easily generate a mind map? Dude, that would be an incredibly interesting, um, that would be an incredibly interesting project to work on. And it's definitely going to be in Rust for sure, 100%. It's going to be in Rust. The entire processing can be in Rust. The rendering is probably going to be in Godot. And later on, if I want, I can set up something for TUI. But I feel like doing it in Godot is going to help me a lot because a lot of the graphics related stuff is going to be handled in Godot by itself. Yeah, dude, that should be an interesting that should be an interesting project to work on. The problem is I need to find incredibly lightweight models, and that's why I need to have a conversation with Gemini about how to get how to get the most out of my hardware in terms of automatic speech recognition. And do I actually have to use ASR models, or is there some easier way? Because, okay, ASR is necessary to convert the audio to text. And then NLP is going to take over for pretty much the remainder of the process, right? But ASR is required because it's speech to text. Like we need something to convert the speech to text. And the words. The thing is, I don't mind a model that might not perform that great, if that makes sense. I don't really mind such a model as long as it's able to capture things that I'm the specific topics that I'm talking about. As long as it's able to capture those specific topics and hand them over to me. Actually, dude, there might be a model that does that, right? That takes a sentence and then just splits it up. Though that would then fall under an NLP model, which is exactly what I'm looking for. So, anyways, I would be using an NLP model, a trained NLP model. Yeah, I need to, dude. Shit, I'm getting like idea. Wait, yeah, I just noticed the time. Holy shit, I need to go check on my food, and perhaps also put some rice for boiling. So I'm gonna take a short break and be back in a couple of minutes. Okay, I'm back, and I have maybe uh I don't know, I would say maybe 20 minutes more. I would say half an hour, but like I don't want to risk burning my rice. So, yeah, probably 20 minutes more, and then I will end. Oh, shit. Okay, give me a second. Right. So, what was I doing here? So we were looking at the filter method, and within the filter method, I was so the filter method takes in a closure. I also just noticed that the filter method consumes it consumes the iterator, and then it returns a filter, which I'm guessing also implements iterator. I think so. Hold on. Um, let's let's do this and true. So it's just returning true the entire time. Closure is expected to take one argument, but it got zero. Okay, right. Now, what is this returning? So I don't think I'll be able to use this after this because it says fn mute, but also, wait, no, it says fn mute. So it's not fn once though. Oh, wait, it's fn mute for the iterator. It's fn mute for the item inside the iterator. The iterator itself, I think, is being moved because it says self. I guess one way to find out would be okay, so first let's make this um, I don't know, v1 iter fill. Okay, impl iterator. So this returns filter, which it's kind of interesting. This returns filter, which it mentions here, here. Actually, does the argument thing work here as well? There's only one file to edit. F. Oh, this is not code. This is just text. Okay. Okay. Can I do that here? Yes, I can do that here. Okay. There it's just text. That's fine. So, okay. So, this returns filter. This returns filter, which also implements iterator. And because it implements iterator, so you can assume that, okay, what's interesting here is that it doesn't mention it doesn't mention filter. It mentions that whatever this returns implements iterator. You see the difference? So the filter method returns filter, right? But then the type that's mentioned here, it says it returns something that implements iterator. Another interesting thing is the item type is reference to I32, not I32 itself. Okay. Now, would I be able to use, would I be able to call filter on this again? it should throw an error, right? Uh, Wait, let's get rid of this and then do this and true. No, this works. So it's not consuming the iterator then, is it? What exactly is it consuming then? Yeah, that's confusing. Like, this is not consuming the iter. Okay, this says creates an iterator which uses a closure to determine if an element should be yielded. I need to I need to look into this. Yeah, I need to look into this because this is a bit confusing. Because it says self, which I usually assume means that the thing is going to be moved this into this function. So if the iterator is being moved into the function, then how am I able to? Oh, you know what I can do? Okay, let me ask Gemini. Okay. I'm doing Rust coding. I created a vec I32. I then used iter to get an iter out of it. I then called filter on the iter. Yeah, on the iter variable. Let's call it that. Filter's signature shows that it takes self and a closure. I'm assuming this means that it. Okay, I'm assuming that this means. I'm assuming this means that it consumes the object. But then why am I able to still use the iter in the next line to call filter again? Okay, uh, it seems to be going the think route in this case, I think. Okay, it sounds like you're encountering the concept of iterator adapters and ownership wrapping. To give you a short answer, you aren't actually using the original iter in the next line. You are using a new iterator that swallowed the old one. Okay, so then my assumption about the thing being consumed is correct. But then there's some quote unquote magic happening later on. Let's read about it. You are using a new iterator that swallowed the old one. Here's exactly what's happening under the hood, why self matters, and why your code works. The signature self means move. You are correct about the signature. Filter is defined roughly like this. Okay. So self, this takes the iterator by value. It consumes, meaning moves, the iterator. And then you have what it returns. It returns a filter. It returns a new struct called filter. Okay, great. The Matryoshka doll effect. Oh, it's that layered like doll within a doll kind of thing. When you call when you call filter, it doesn't delete the original iterator. Instead, it creates a new wrapper struct that owns the original iterator. Think of it like nesting dolls or an onion. Step one, you call vec.iter. You have an iter struct, type iter, okay. Step two, you call filter. This method eats, quote unquote, eats the iter and puts it inside a filter struct. The type of this is filter of type iter. Step three, you call dot filter again or dot map. This method eats the filter struct and puts it inside another. No, hold on. Back up. Okay, okay. Oh, there you go. Wait, wait. Oh, this is a, wait, hold on. I think Gemini understood what I was saying wrong. Hold on. Are we getting an error here? Hold on. Let's see first. So we've used v1 dot filter and then we use this dot filter. After I save, there's no error. I could use it multiple times and there's no error. There is no error here. Hold on. Let's do underscore iter underscore fill 02. Still nothing. Nope. Let's do v1 underscore iter underscore fill 03. Still nothing. Sorry, zoned out. Okay. Um, hey, so in your code, in your example code, you mentioned that you showed, you mentioned in the comments that the second time calling i.filter would throw an error, but that doesn't seem to be happening on my end. That's why I'm confused. Hold on just a second. Okay, let's comment this out. You're joking, dude. Oh my God. Are you kidding me? This is crazy. This is insane. Just because I didn't fill this up properly, so it wasn't displaying the errors on the other side. That, okay, well, the question is answered. Hold on. You are right that filter consumes self. However, the code works because the specific iterator returned by so-and-so implements the copy trait. Okay, now I think it's bullshitting me. Hold on. Wait. Wait, hold on. hold on. Use of moved value v1 iter. So that's where our error is supposed to happen, and that's what's happening here. Okay, so we can delete these. Okay, back up. I noticed in my own code that a couple lines down there was um, an incomplete. There was a line where I tried to call filter on another separate uh, iterator, on another separate iter, and I hadn't given it any arguments. So the Rust analyzer was giving me an error there, but not giving an error for any of the above lines. As soon as I commented out that line, it showed all the other move related errors. Okay, I think it's using this thinking thing. Okay, this makes total sense. You have just experienced compiler error masking or cascading errors. You were right in your original assumption. Filter consumes the iterator. The reason you don't see the red squiggles immediately wasn't because the code was valid, it was because the compiler gave up before it got that far. The compiler pipeline. The Rust compiler and Rust analyzer runs in distinct stages. It generally looks like this. Parsing, did they type valid syntax? Type checking, do the functions have the right arguments and type? And then borrow checking, are the ownership and lifetime rules being followed? Oh, I thought this was a line by line thing, but no, this is like different phases or stages. And in this case, so we have parsing and we have type checking. Do the functions have the right arguments and types? So that's stage two. And then borrow checking is the last stage, which is why it didn't show. That is interesting, dude. Hold on. I was thinking it's like it's a line by line kind of issue. Wait, let's reproduce the error. Okay, so we have the thing here. Okay, I'm gonna yank this and bring it up here just to, yeah, there you go. Okay, so it's just not gonna bother showing any of the other errors if this stage isn't passed first. That is so interesting, dude. We learned something. That's holy shit, that's crazy. I need to look into this more. What's the time? I don't want my food to burn. You know what? Yeah, I think I will end the stream here. Give me a second. Let me see. Um, okay, I don't want to like raid and run because I just don't like doing that. I had to do that the last time and I didn't like doing that. If Louise was live, I could have gone to her stream because she's usually in like, you know, those cycles. Like there's like the 40-minute thing, 40-minute study session or work session, and then I don't know, 10, 20 minutes of break, or maybe it's a 50-minute study session and then a 10-minute break. I don't remember. Let me just look her up because usually her thing pops up here, and then I'm able to see that she's live. I don't think she's live today. Yeah, that might be it. You know what? No, I don't wanna raid and run. So I'm just gonna end the stream here. Just so my food doesn't burn, I need to go check up on my food as well. That's gonna be it for today's stream. We are now officially, I think, um, 3 weeks we have been constantly streaming. We have been what's the word? Not constantly. I mean constantly, yeah. But 3 weeks we have been continuously streaming, and that's pretty awesome, dude. It's a pretty it's a pretty good start to the year. Let me say that it's been a pretty good start to the year, and I'm hoping it remains this way in terms of my research and my progress with deep learning and data science, and now my progress with Rust as well, because there's a shitload of things that I want to do with Rust. Holy shit. It's going to be insane, dude. It's going to be insane. And in terms of doing creative coding, once I get this Godot plus Rust thing up off the ground, there's going to be so many things that I can do, including game dev, not just limited to game dev, including game dev. There's going to be a whole bunch of things that I can do. But yeah, okay, I'm going to continue exploring this iterator thing. Dude, I could very easily just breeze past this by just focusing on filter and then focusing only on map. But there's just so much that I'm getting to learn from from like poking around in different areas that I just don't want to move past it until I've understood all of these other things. Because like the fact that I didn't move past it in this case, like today we got to learn that, hey, this is how the compiler does its compilation. It does it in like various stages to detect various types of errors, and based on which stage it stopped at, you're going to get that set of errors. So that's pretty interesting. But yeah, okay. So